to hit start on record, Catherine. I got it. Yep. You got it. Yep, exactly. So what is Stable Diffusion? So Stable Diffusion is actually not a really new thing. It's actually an artificial intelligence technique that's been around since about 2004, 5, somewhere in that range. But it was very difficult to use because it's extremely computationally intensive. Basically, it falls into the category. Let's see if I can get my presentation to move here. Sometimes when you first start recording, it kind of glitches. It's like, be good, little box. There we go. All right, so what is Stable Diffusion? It's one of a large class of something called a generative neural network. So let's break those two words apart for a second. A neural network is just a computational model of brain functions. It doesn't have to be human brains either, by the way. It could be mammal brains, could be animal brains, could be whatever. But it's a piece of mathematics that's related to brain functions. The generative part comes from its internal structure. So normally a neural network, you put a similar input in, you get a similar input out. So for example, you might put a series of numbers in and get a forecasted prediction of a number out, like predicting the temperature tomorrow. In a generative neural network, you put in one particular type of input and you get a completely different type of output. That's the generative part of the story. So in this case, structurally, it mimics brain functions in the brain's core. Stable Diffusion in particular starts to work on something called the hippocampus layer. So this is where we store long-term memories. Frequently, it's used for converting text prompts to images. So we give it a piece of text to describe what kind of picture. If you've ever played Pictionary, it's kind of like you try to give words to your friend and they try to draw the picture that you have in your mind and see if you can get the idea across. Some really common trade names that you may have heard of in the media. DALL-E is one of the open source models that's been around for a while. Midjourney is another one. Copilot image generator is part of the Microsoft suite of AI stuff that you can use. And there are literally hundreds of these things now. Adobe offers one as part of their product suite. We were just talking beforehand, Catherine and I, that Canva, one of the pieces of software that we often use in schools, now has an online image generator you can use. There's a lot of them out there now. They're trained from millions of captured images with captions. That's actually one of the good things about as more websites have added supporting text for people who use screen readers. A lot of times those captions are embedded into the picture now, which is actually very useful. In this case, we have image in, text out. So we put in a picture, all of its pixels, and we try to associate that with the text. Then when we want to use the model, we turn everything around backwards. We put the text in and get the picture out. If you put in exactly the same text as you trained with, in theory, you should get exactly the same picture. But oftentimes it's not exactly the same. It's very close, but it's not exactly perfect. By the way, sometimes those captions are auto-generated. That leads to some kind of interesting noise in the training process. If you have an image with no caption, you use another piece of AI to give it a caption and then train the second AI off the first AI's output. And that starts to create problems that are a little bit like making a photocopy of a photocopy. You start getting some feedback things that kind of mess stuff up. So figuring out this training piece is a whole science of its own. They are notoriously energy inefficient. Training the latest DALL-E model consumed about the same amount of energy as all of Peoria County for 6 weeks. So it is extremely energy intensive. And then operating one of those models, every time you say, hey, please draw me a picture of a dancing bear on a ball, it consumes about the same amount of energy as it takes to charge an iPhone once. So they're extremely energy consumptive. That's one of the things that's a big bugaboo in my field. And I'll talk a little bit about that as we go. Increasingly powerful things called NPU, neural processing unit, or other high-end GPUs, graphics processing units, make it possible to begin to operate some of these models outside the cloud environment. I mentioned that Stable Diffusion has been around a long time, but previously we could really only operate it on, well, back in 2004, practically supercomputer resources. Now it's possible to operate them on very healthy local pieces of hardware that have dedicated components. This laptop that I brought this evening is one of those. So it has both a GPU, graphics processing unit, but it's also one of the first that has an NPU, a neural processing unit. So it basically has a dedicated piece of hardware on the inside specifically for running neural networks, which is actually what we're going to use tonight. So that's kind of enough about what we're going to play with. Let's actually go try the thing. I think that helps a lot. So I decided I really needed a nice text prompt for this evening. And I decided the best text prompt I could come up with was draw a picture of a Mexican cantina with an evening sunset. A man in a serape is playing guitar sitting just outside the front door, and we can see mountains and cactus in the background. What I'm going to do is actually step out of our PowerPoint presentation for a second and take you over to an interface that I have set up to use Stable Diffusion. And let me load this up again here real quick. Wait for it for just a second to recycle. And what this is doing then is it's basically the interface to the low-level code that's actually running the neural network itself. In this case, I'm running something called Stable Diffusion XL, which is one of the larger models. And I've conveniently kind of put all my text in there. So I literally just type in the text, draw a picture of a Mexican cantina with an evening sunset. Man at serape is playing guitar sitting outside the front door, and we can see mountains and cactus in the background. When I hit generate, what's going to happen is behind the scenes, it will try to pick out the key pieces of text. Things like the word of and a are not terribly interesting in drawing the picture, but there are certain things, right, like cantina, guitar, that actually matter as far as nouns. And then it'll try to pick up the adjectives. Well, what kind of guitar? What kind of sunset? What kind of thing? So it'll try to both pick out the nouns and the descriptive words. That gets fed into that neural network. And when I hit generate, it's basically propagating that through the entire structure. So our words come in at the top, you might say, if you imagine it flowing from top to bottom. The words come in at the top, and as it percolates through many, many, many connections, each one of those output connections sets a pixel. That's red or blue or green or whatever color. So in this case, I'm generating a relatively small one. This is 512 by 512, kind of like an old picture. I'm mostly doing that for convenience sake here. If you have more time, you can generate pictures that are much bigger, of course. But in this case, you'll notice that it's generated a very small image. Then what it's going to do is the diffusion part that actually blows that small image up into the target size that we want. That's what it means by diffuse, in that it propagates out. Think of it like blending from pixel to pixel. So it's currently generating that, and looks like it's almost done. There we go. So here's our picture. So we have a man, we have a guitar. Not so sure about the cantina. Can't prove or not prove that's a cantina. We definitely got our cactus, and we got a little bit of a sunset type thing going on. But if you look really closely at the picture, there's some kind of oddities too. The guitar, is the guitar on his back? Is it in front of him? Is it, I mean, it is a guitar. That part I can kind of recognize, but I'm not quite sure exactly what's going on. Is that a fish up in the sky or an upside down bird, or what are those? Are those some kind of clouds? Again, Stable Diffusion will generate a pixel map and then diffuse, make it direct to the picture. But it's kind of hard to go backwards to go, well, why did you draw that? Neural networks do what they do because that's how they were trained. And one of the prices we pay for using them is you can never really ask them why. They do because that was in their training set. That's what they do. Now, you'll see also when I jump back to my presentation for a second, when I tried this previously, I got a different result. In this case, I got this one. So I got the man standing in a doorway. I'd asked for sitting, but I got standing. I guess I'll take that. I got a guitar. The guitar looks a little more plausible, kind of. We got a cactus, kind of. I mean, I guess it's a cactus, and a pretty abstract picture overall. So what I can do, jumping back to Stable Diffusion, is because the diffusion model is semi-stochastic, so it's partially random. If I hit generate again, I won't get exactly the same image. It'll reinitialize the neural network, look at the words in a different order, and possibly give me something completely different. Now, it should be in the same theme. So it should still have a cactus and probably a man and probably playing guitar and probably a cantina, but it won't draw exactly the same picture. So it's interpreting the text as if it's a theme rather than strictly input to output. That's one of the things that makes this generation of artificial intelligence really interesting. Up until now, most computers were put this in, get this out. Now it's you put this in and it's kind of a suggestion and you get something kind of fuzzy out. In this case, we'll say it's blowing this back up. Seemed to miss the guy with the guitar. Don't know where that went. But we got a little bit of a sunset. We definitely have some cactuses there. I can't prove or disprove that that's a cantina. Kind of interesting. I like the awnings in front of the picture this time. When I ran this previously, I'll just show you a few examples of what I got last time I played with this. I basically told it to regenerate it several times. So I got this one. So we got our man. He's standing in with a guitar. We have a sunset. I can actually see the sun this time. The only thing I kind of wonder about in this picture, this looks like kind of a lunar surface or something going on here. And where'd my cacti go? Apparently the cacti were not interesting to it that time around. This one, I got my cacti back, but they appear to have had some kind of horrible nuclear accident. I'm not quite sure what really happened here. That might be a dinosaur in the background. I don't really know what that is. I definitely got a guitar. This is good. Maybe it's a cantina. Yeah, but I didn't really get the sunset I was after. It's not bad. How about this one? Not too terrible. I got the really very pretty colors in the background. And I've got some barrel cactus, and I've got some kind of a saguaro looking thing, and the world's tiniest guitar. There is a tiny little guitar, and for some reason it decided not to emphasize that. So it didn't really put that, I don't know, it's not even a mandolin. It's like a little ukulele deal. I don't know quite what was going on with that. So yeah, definitely it's very anti-serape. Yeah, it's not into, yeah, we're just not getting serapes tonight for whatever reason. Yeah. Exactly. So one of the things that you'll hear about in the media is this idea of something called prompt tuning. The idea is that if you don't get exactly what you're expecting, maybe you can go in and make changes to the prompt to kind of give it other hints and see what you can do with it. In this case, I'm going to try this. I'd really like a photorealistic picture. Can you give me something a little more photorealistic? And by the way, my cantina, I'd like a bar and people dancing inside. A man in serape playing guitar is sitting just outside the front door, so I'm going to try rearranging the words. There are mountains and cactus in the background. So let's go back and edit our prompt. Pop this right in here. Draw a photorealistic picture of Mexican cantina with here we go, a bar and people dancing and an evening sunset. And then let's also change that to a man in a serape playing guitar. Man in a serape, oops, missed that. Man in a serape playing guitar is sitting, change it like that, is sitting just outside the front door. There are mountains and cactus in the background. So let's change that to this, change it to another sentence. There are mountains and cactus in the background. Good. So now I have my new prompt. Again, we'll run the same process. So we hit generate. It's going to tear apart this sentence, which I've reordered the words a little bit. I've changed, from one sentence to a different number of sentences, 3 sentences. I'm hoping that this will then pick up a little bit different emphasis, right? To us, it sounds like exactly the same language, but to the AI model, we've changed the input in a way that makes it process those words a little bit differently. And if you think about it, that's kind of what humans do too, right? If I told the story very quickly, somebody like quickly scribbling, to your point, maybe they don't quite catch the serape part, or they're not sure what a serape is, they don't draw it. Maybe if I emphasize it differently, I can get a little bit different result. That's one of the things that makes these both interesting and also kind of frustrating. You know what you want and you have a picture in your mind, but that doesn't mean that the AI doing the drawing knows what you want and can do it exactly the same way. In this case, we appear to have gotten what I will call aggressive cactus. We have a cactus with many branches, which is kind of interesting. A little bit more of the Southwestern style building. That part's pretty good. Our gentleman has, I don't know, kind of an interesting cap. Something terrible happened to the neck of the guitar. I'm not quite sure where that went. We still have a guitar body, but I don't know where the neck went. I'm not sure whether this is a Is this actually a cactus or more of a chainsaw? I'm not really quite sure where that's going. And I still have to kind of take it on faith that this is a cantina. It looks like a building with a door. Maybe it's a cantina, maybe it's not. When I did this before, so when I was preparing for this, my original image looked like this. And when I regenerated it, I got this. And this is a little closer. We've got our guitar. I think this guy is dancing, maybe hopping up and down at least. Looks like one foot's off the ground, something. This could definitely be a cantina. We have glasses of something sitting back there and some kind of a canopy kind of a deal. We have our interesting cacti collection again, but there's something kind of funny about the sunset in the background, right? It's sort of, yeah, it's kind of like an MC Escher, background. It's sort of like the sun in the mountain in the sun. It's a profound statement. I don't know where it was going, right? But definitely odd. Definitely odd. So I said, well, maybe if we try what's called negative prompting. So the way these Stable Diffusion models work, not only can they look at a positive prompt, draw something like this, you can also give it a negative prompt that says, don't draw something like that. So in this case, whoops, sorry about that. Be good, PC. There we go. So I'm going to basically give it the same prompt I had. I'm going to say negative prompt, cartoon or pixel art. I'm really trying to convince it that I want something more like a picture. And see if I can convince it, hey, I want something more realistic. I want something a little bit different. The question is, has it ever had any training to try to point it that direction? That's another interesting limitation. It can't try to draw something that's never seen an example of. So remember that it's trained from existing images and existing pictures and existing things. Perhaps its catalog of training material, since this is an open source model, you could go explore it, but it's also about 1 million pictures deep, give or take. And this time, hey, maybe we're getting somewhere. Here we've got the fuzzy version. Diffusion will then crisp that up as it tries to fill in the rest of the pixels, draw the rest of the image. Yeah, looks like we're going to get our pretty sunset in the background. That's kind of cool. Here we go. Let that snap in for a second. Ooh, there's your serape. All right, so we got our serape or something that's probably close to it. That's either a guitar or a chicken. I'm not quite sure, but I think it's a guitar. So that part's good. This isn't really a cactus, but it's a desert plant. All right, we're kind of going the right direction. Pretty sunset. We got some mountains. This maybe is a view from inside the cantina looking outward. Yeah, that's not terrible. In fact, it's so not terrible, I'm actually going to save that one to use later. That's not bad at all. When I tried this before, here was our original picture. Here was our modified prompt. And when I added the negative, I got this. So again, okay, well, I've got my cacti. That looks good. There's some kind of a sign here. It's some kind of Elvish. I don't really know what that is. But maybe it's the cantina sign. We have people, looks like this guy's drinking a beer, so that's possible. We have a person playing guitar, and we have another person. I do not think that's a guitar. It's maybe a cello. It is huge, massive guitar, but it's looking like it's kind of working. We're sort of coming around, right? But here's the funny thing. So the whole time we've been doing this, right, we're limited by the size of the model that I can run locally on this machine. As I mentioned, I have a dedicated neural network processor inside my PC. What could I get if I used a much bigger system? So in this case, I threw the exact same information in a prompt to Microsoft Copilot. So Microsoft Copilot uses a supercomputing system called the Azure Cloud. So it has hundreds or thousands of NPUs and GPUs. So it can do much bigger, much more capable things than I can do. The price we pay is that every time I use it, I consume quite a bit of energy. So when I asked it to do that this time, I got back this. Yeah, much more crisp. Here's our gentleman playing the guitar, very nice serape here. We've definitely been into the beer. There are many, many, many beers. We've got our guitar. We have a person sitting at a nice table back here. We've got a pretty sunset. We've got a cat. No, it tried. It got in the neighborhood of Cantina at least. So that wasn't terrible. I think maybe this person back here is like playing violin or adding in, and we have quite the selection of things in the bar. Pretty impressive. I went ahead and regenerated that several times on the big computer, and I got some different collections here. So this gentleman is playing, a little bit fewer beer bottles sitting around on the pavement this time. We have a bigger crowd sitting in the back. You can almost imagine this person's kind of sitting there and listening to the person playing. We're starting to get kind of more of an artistic expression kind of a thing. I am not sure what kind of birds these are or which direction they are flowing. I think one of them looks like a duck. One of them looks like a goose. This one's kind of lopsided, but it was trying for something here. It was trying to put something up in the sky. We definitely get our sunset. And we definitely got kind of a beach scene going. This one, hey, it learned how to spell. It got cantina right. That's pretty good. So if you didn't know if this was a cantina, it's definitely a big old cantina. Our gentleman here has diversified. Now we have some beer. We've got some wine. We've got a little bit of everything. He has not one, but two guitars, just in case he wants to change keys or something, I guess. Lots of desert plants, lots of cacti. Yeah, this is starting to look pretty crisp. It doesn't quite meet the photorealistic thing. It doesn't really look like a photo, but it's definitely going the direction we'd kind of like it to go. This is the last one I generated. He just brought the whole case of beer with him this time, so let's forget the cantina and just take care of our needs ourselves. Now it looks more like he's looking into the cantina rather than he's playing at the cantina and somebody's looking into him. We never really specified, did we? It could have gone either way. You regenerate, sometimes you get one thing, sometimes you get another. Person in the cantina looking at the person, people in the cantina generally ignoring the person looking at the people in the cantina. We never specified, so any of those are probably reasonable interpretations. Could be any of those types of things. Which kind of then makes us pop back for just a second and go, wait just a second, are we being creative? I mean, we're the ones providing the text prompt, right? I mean, I could have told it to draw a collection of puppies on a beach, right? Or maybe a bear with a ball or whatever. Is that the model being creative? Or is the model just doing our bidding and we're the creative thing? That is a really interesting question. I mean, the model's doing what we're telling it to, but who's doing the creative part? That's not quite so clear, is it? Which kind of lets us pat back to a second to how does creativity work in humans anyway? Be perfectly honest, we don't 100% know. But there are kind of three major prevailing theories, and there's some new research that's kind of giving us a very different perspective. By far, kind of the most common creative theory is something called associative creativity. You'll see that written on by Aristotle. There's another gentleman by Piaget, who's a person who studied how children learn. It's generally referred to sometimes as the simile method. A is like B. But basically, associative creativity works something like this. We start off with some kind of a problem. In this case, I have a bunch of dead bugs in my windowsill. So I'm out in my shop. I have a windowsill. My windowsill's very high. I can't necessarily reach it. That's my situation. Then I have a problem. The problem is there's no easy way for me to clean these up. The window that I'm thinking of in my workshop is way up high. I'd have to go get a ladder to clean it up. I don't really have an easy way to clean these bugs up. That's my problem. The associative part comes when your brain maps that to something else you know. So once upon a time, my kid dumped Cheerios all over the carpet. And Cheerios are kind of small and round, and bugs are kind of small and round. So it's kind of a similar situation. And when I needed to solve it, picking those up by hand would have been really, really tedious. Hey, that's kind of the same problem. There's no easy way to clean them up. Hey, there was no easy way to clean them up. The creative part comes when we match these things together and we say, back when I solved this old problem, I used the vacuum cleaner to clean up the carpet. I didn't try to pick them up by hand. I used the vacuum cleaner to do the job. So then the creative process says, well, if that's how it worked before, then maybe the new solution is get an attachment on the vacuum cleaner and use that to clean up the bugs, quit trying to pick them up yourself. So people who study creativity will argue that associative creativity, the process that I just showed, accounts for about 70% of the things that people do in a creative life. That the vast majority of things are associating prior experience with new experience. Piaget's argument was that the best thing we can do for children is give them lots of experiences, go many places, try many things, give them as many different possible conditions, because if they have many, like a huge library of the things in the green, when they encounter something new, like the thing in the yellow, they'll have more to draw on. So that was kind of his theory about why and how we should teach children, give them lots of different diverse experiences. Now, that wasn't the only theory. Another big one is something called the abstraction cycle. This is by a guy named Gendrich Altschuler. Really interesting guy from a historical standpoint. He was a cognitive scientist, but also an engineer. He was in the United States. He got really frustrated during the Vietnam era, went to the Soviet Union, defected, and then wound up working on this same thing that's now called the trees method. Essentially, what he argued is that the way people are creative isn't necessarily associative, trying to associate something concrete with something else concrete. It's actually about making abstractions. So his method would say you take a specific problem, you map that to what he would call the general problem. In trees, there's a very formal, T-R-I-Z, it's pronounced trees. It's actually a Russian acronym, but essentially it's called abstraction problem solving is roughly what it translates to. In this case, what trees does is say, well, your problem is you need to clean the dead bugs out of the windowsill. The abstract problem is I wish to reduce the density of something in a space. So the abstract solution, the generalized solution, is if you wish to reduce the density of something in the space, increase the space, decrease the matter, or make the matter more transparent or able to pass through. So then when you map that back to the specific solution, that would result in three possible solutions. One is your problem is that you have too many dead bugs in the windowsill. You need a bigger windowsill, make it less dense. That's a possibility. Maybe I just need bigger windows so that those few bugs don't make any difference to me. The second thing I could do, right, is to say, oh, so I've got this less dense collection of bugs. Maybe instead what I could do is change the density of the bugs. I could put a screen in so only the little bugs get in instead of the big bugs. Maybe I could do that. It's kind of like thinking by analogy, and it sort of works better on some problems than others. I've linked a couple of things here that you can come back and look at later where you can actually try this process out, put in your specific problem, and it'll guide you to find the generic problem, the generic solution, and then the more specific solution. People who study this kind of thing would say 70% on the first cycle. Abstraction cycle accounts for about another 15%. So it's not used as often as associative is, but it's really important to be able to generalize and then become specific. Which sort of leads to the third one. The third major theory is something called Gestalt. Gestalt, Wertheimer, Kafka, those guys were kind of all in this camp. And they sort of come from the idea that the whole is different than the sum of its parts, or the whole is greater than the sum of its parts. In that version of creativity, people believe that it's not the individual items in the scene or the pieces of the problem that matter. It's being able to look at the entire whole and recognize what's present and what's missing. So the example picture that I got from this source, if you have, let's say somebody gives you a gift of a box of chocolates, you could think of it as a whole bunch of individual items, or you could think about items in rows or columns, or you could think about their color, or you could think about the box that they came in and not think about the chocolates at all. Or maybe what really matters is, was it important in how they wrapped it? Were they trying to hold it shut, or were they trying to say, hey, come open me? In the bottom section, ooh, the label maybe matters more than the other label because one is crossed out and the other one is surrounded. But all of these things basically come down to how well can you look at the entire picture and identify the things that are missing or the things that need to be added. It's a very all at once and all at one time. Sometimes people refer to Gestalt as the lightning bolt theory. You basically have this entire big picture, and out of the clear sky, you suddenly recognize there's something there, something missing. When I got to thinking about who is a great example of this whole Gestalt creativity thing, one person came to mind. Some of you will recognize this character, some of you will not. There is a famous character who was actually a book, later became a very popular TV series called Columbo. Anybody familiar with that TV series? Y'all know Columbo? Okay, some of you know Columbo, some of you don't. What you need to know about Columbo, if you don't know this guy, is that he is very much a Gestalt thinker. So he solves crimes, used to be either every week or every other week on TV. He looks at the entire picture. Usually it seems like he's solved the whole thing in the first 5 minutes, but he doesn't reveal that right off. In fact, his way of doing it is kind of more like this.
Oh, one more thing before I forget. Oh, listen, there's one more thing.
What, something else?
I don't know what's the matter with me. One other thing, the angle of the bullet. Oh, Mr. Franklin, actually, there is one thing.
That one thing.
One thing I almost forgot. Yeah. Oh, General, talking about work, there's a couple of loose ends I'd like to tie up. Nothing important, you understand, but, oh, listen, one more thing. It just take a second.
Seeing the series,
oh, listen, just one more thing.
Up and tells you
there's one little thing.
Yeah, might as well confess, because they've already got
there is one thing that I did want to ask you, sir.
And the rest of the episode is usually him tormenting the guilty
Clayton.
party into confessing.
Gee, I almost
they
forgot.
basically
This is fascinating.
have done the
There's
terrible
one other
thing.
thing I wanted to talk to you about.
But the
It's rather
process.
Oh, listen, there's one other thing I wanted to ask you about.
Oh, almost got out the door too bad. Oh, the night. No.
I'm sorry to bother you, ma'am. I just wanted to ask you one
Just
more
one more
question.
thing.
What is it?
Oh, the night, right?
Oh.
This guy stops. He's always looking at the big picture and finding that one thing that doesn't quite connect. And that one thing that doesn't quite connect is usually the thing that means you're guilty. He is fantastic at it. If you've never seen the show before, I highly recommend you stream a few of them, especially from the first few seasons. Last two are a little weak, but the whole beginning part is fantastic work. The actor is Peter Falk is just incredible in that particular show. One of my favorites. So maybe this whole creativity thing works kind of like this. We start with some kind of a need, and we start with some kind of a tool at our disposal, whether that's associative, whether that's the Gestalt theory, maybe it's the abstraction process. We put all that into some kind of effort. You have to cognate on it, right? You have to think about it, put some effort in, and then boom, you get some kind of creative product out of the end. Maybe that's how it works, and generally that's what we've thought really for the last, golly, if you go all the way back to Aristotle, thousands of years. But that's kind of been the theory, but now there's some new things that we're starting to learn that might change that. If those are the correct theories, then this leaves us with a whole bunch of questions that we don't have answers to. Question one, should scientific creative works be treated any differently than artistic forms? Here in the United States and generally across the world, scientific works are protected by something called a patent. Artistic works are protected by something called a copyright. Generally speaking, patents are much stronger than copyrights. My pictures that you saw there that I had generated, each one of them can have a unique copyright. But the process for generating them, they can have a patent and then nobody can reproduce the process. Really? Is that the way that should work? Because now we're saying that the process is more important than the creative output? Or is that really what we meant? Or is that just the way the law evolved? It's actually a really excellent question. Second one, is all art and literature just derivative? There's some people who look at creative story writing, for example, and will say that actually there's only 10 possible stories. They're all the same story. They're one of the 10 standard recipes, but they're all told differently. But the form is always the same. You could argue that the different major movements in art, whether that's abstraction or realist or whatever, they're all just derivatives of each other. In fact, when an artist is training, we usually have them reproduce the master's work first, and then we let them go paint their own things. When does creative work become plagiarism? On the university campus, this is a huge bugaboo. If you cite your sources, that's good. But at what point is citing your sources kind of blend into you've created your own thing? That's a really big question, especially in cases where there's one student in particular I'm thinking of that was working on a master's thesis, that they had a diagram in their thesis that was remarkably similar to a diagram in another paper, but it wasn't identical. So how close is too close? Is it the orientation that it flows from left to right or top to bottom? What if she just picked different colors but got different results? This is a huge question, and we don't really have good, clean answers to it today. Does it really matter which tools we use? Within the artistic community, particularly people who draw pictures, Stable Diffusion is universally hated. This thing is ripping off all the artists. We're all going to be doom and gloom, and we will never make any money again. What I find interesting about that from a historical perspective is I've heard this before. This happened when the camera was invented. When the camera was invented, everybody went, no, nobody's going to pay me to draw current events. If you go back to the Civil War era, right, we had people who didn't take pictures. There were some, but they mostly did drawings. And the people who were doing the drawings back then were like, oh, with the age of the camera, we're all going to be out of business. Is Stable Diffusion really any different than the advent of the camera? Or is it different in the sense that it's more easily manipulated? And even a clown like me can sit up here with standard diffusion and draw many pictures of a person in a cantina. It's a really interesting question. Does anybody actually create anything original? I mean, if you really buy into the Aristotle Piaget associative thing, there isn't anything original. Everything is associated with everything else. The abstractionist thing, you have to have something to abstract to, so that doesn't really play either. Gestalt, we don't really know how it works. Maybe. So is anything truly original, or is everything derivative of something you've already experienced? That's a huge question, which leads to, if you train neural networks, well, everything a neural network does is just derivative of its training set. That's true. It's true of you too. How do you counter that argument? How does society what is good creativity and bad creativity? Obviously, I picked a very family-friendly, safe set of pictures this evening. It will shock you not, probably, that there are lots of people putting in prompts of drawing things that are not very nice. And then who decides what's not very nice? That's a whole nother kettle of fish, right? How do we know when an AI has creative intent? Ooh, at some point, somebody's going to get the clever idea of having one AI talk to the other AI. And at some point, something unexpected will happen. Is that an indication of creativity at work, or is that just a lucky break and a random draw? We don't really know. Where are the boundaries around all these things? Part of the reason we struggle with this in the artificial intelligence space is because we're still struggling with it in the human space. We can't really ask the AI to do something that we can't really explain. It's doing it, but we don't really understand the boundaries about how everything works. And that makes it very difficult for us to know how to interpret or what to do with it, right? But there's one other critical piece, and that's the most important thing I wanted to share with you, is this is still an ongoing study. We're still trying to understand how creativity works. And in particular, there's been one breakthrough that happened about 2 months ago that, for people like me in the neural network field and folks that work in artificial intelligence, I think this is, predictions are always dangerous. I think this will turn out in 100 years to be one of the biggest aha moments that, wait a minute, maybe we've had this all wrong from the beginning. What these images are images of what's called the activation of the firing of neurons in different parts of the brain. Frontoparietal, limbic, ventral attention, dorsal attention, sotomotor, visual cortex. Basically, these are all the things happening around your brain. Unfortunately, the people who published the paper, it's still in preprint, didn't have animations in there. It's kind of hard to do animations in a 2D paper. But their work is all based on animations, looking at things in real time. The reason they were able to do this is because now we have new sensors that both stimulate the brain and also read the signals back. They're mostly used in this case for people with very severe epilepsy. So by being able to regulate motor control, you can help people not have seizures and things of this nature. But at the same time, it also gives you an amazing ability to see what's going on inside the brain in real time. And this was the big surprise. What they did was they had people who have these things in their brain try to solve what we would call common creative problems. One of the common ones is you dump 100 paper clips on the desk and say, build me the tallest tower you can, right? Or you can say, hey, I've got a problem that I'm trying to solve, and you give them kind of a standard creative prompt, and you watch what happens. In this case, you're not as interested in what the outcome is, whether that's good creative or bad creative or whatever. What you're really interested in is how does the brain work? And the surprise is the bottom 3 sets of pictures. Turns out that this thing that they call the default mode network is running all the time. In fact, you could argue that the default mode network is the measurement of consciousness. These are the things that when you're asleep, when you're awake, all of these things are constantly running. And they're running in very interesting spaces. The left-hand picture, these are the parts of the brain associated with the optical cortex and with things like smell and sound. These sections in here are part of the experience network. This is your deep learning, the things you remember from years and experiences past. These pieces, they have to kind of turn the brain this direction, look at it from the top front. These are part of the what's called action initiation section. They're the part that initiates action that eventually goes to the motor cortex to tell you to move your hand, move your fingers, do whatever. But it's the initiator that starts that. And what they found, and this is the mind-blowing part, is that the default mode network runs all the time. And when you're being creative, what actually happens is other portions of the brain are suppressed. They're not turned on. So when you're really being creative, what's happening is not that you're turning on a part of your brain. It's that you're turning off the part of your brains that prevent you from being creative all the time. It's kind of like focusing attention. You are a creative thing. You're always creative, but sometimes you probably need to make lunch. So you use a little bit of creativity, but you're mostly focused on getting the bread out of the cabinet and maybe picking up some stuff you're going to put on your sandwich, right? Or maybe picking out the chips. Or maybe you really need to be creative because you've got a flat tire and you don't have a jack with you. That's going to tend to, that default mode network is always running, and it's going to suppress some things and let other things through. If this is true, and again, it's still early research, then everything we've done on AI and creativity is completely wrong. What that means is that we are creative all the time, and what we should be modeling is what suppresses creativity, not what makes it happen. Because left to your own devices, you are creative. You just didn't know it. So I was trying to think of a really great example to kind of explain this. And I decided to go back to another scene from a movie. So if you're not familiar with this particular movie, it's one of my favorites. It's a movie called Chicken Run. If you have never seen Chicken Run, treat yourself. It is a fantastic claymation movie. It's very kid-friendly. Do this with your kids. I am an adult and I love it to death. If you're familiar with other great movies, you may have heard of a movie called The Great Escape. It's very similar to The Great Escape, except that it's about chickens, and the chickens are trying to get out of the barnyard because they have to lay eggs until they wind up going to the, going and becoming chicken dinner. So there's a newcomer, the chicken on the right here with the little bib. His name is Rocky the Rooster. And Rocky is a newcomer to the barnyard and has figured out that what you people need to do is fly. Now, if you've ever seen a chicken try to fly, it's not a good thing. So at this point in the story, they've spent days and days and days trying to fly, and it is not working. So Rocky has one more idea.
I don't see what this has to do with...
You will. We've been working too hard. Time to kick back a bit, shake those tail feathers.
Look at him, nearly podging around like a... Oh, good heavens. What's happening?
That's called a beat, sister. Feel it pulsing through your body?
Oh, yes. Pulsing. Fancy that.
Hey, well then go with it, baby.
Oh, my. Look, I'm going with it.
What's got into you?
Same thing that's got into you.
Flop, fly. I don't care if
Just
I
go with the
die.
flow, pal. Let it go.
I don't care if I die. Don't ever leave me, don't ever say goodbye.
call authorizing a halt.
Oh, shut up and dance!
Always somebody who doesn't want to make creative process.
What are you sobbing about, you Nancy?
Little moments like this, mate. It's what makes the job all worthwhile.
Our rat friends here have been stealing all the things. All right,
Gonna dance?
gonna dance?
Yeah, all right.
Give me one more kiss and hold it a long, long time. Give me one more kiss and hold it a long, long time. Love me, baby, till the feeling hits my head like wine, so fine, so glad you're mine. Flip, flop, fly. I don't care if I die. Flip, flop, fly. I don't care if I die. Don't ever leave me, don't ever say goodbye. Don't ever leave me, don't ever say goodbye. Yeah, don't ever leave me, don't ever say goodbye. Yeah.
Ah, but
Did you see that? A flew!
flew. Maybe I hope you've enjoyed our conversation this evening. Maybe what it takes to be creative is once in a while just kick back and let it go. I hope you enjoyed it. That's what I've got for you today. Hope you had a good time. So very cool. I can field a few questions. If anybody's got a few, or we can try a couple of other drawing prompts and watch what happens. I'm all into watching really strange things happen with computers. So any questions, stuff you might have? Yeah, shoot.
So how does the training set work on the model that's in there and stuff?
Right. So in this case, I have a pre-trained model loaded on here. So somebody else has already done all the training work. I've taken the resulting neural network weights and structure, and I'm running them here. Mostly because training a neural network takes thousands of times the compute power as running one. So pretty much still we're limited on training to having to train them in the cloud. We can train very small models locally, but it's very slow. Where do we get the data from? That is one of the big bugaboos. Right now, a lot of the folks working on this will say anything on the internet is fair game, without regard to copyright or any of those types of considerations. Fair use, they're screaming fair use, yes. Some other groups, Adobe is one of the more interesting ones, their claim to fame is if you come use our AI model, we will guarantee that it was only trained on images and captions we had permission to use. So if you're a business, you're not going to get sued over copyright because we owned the copyright or had access to everything that we trained it with. And I think that's likely to be a wave of the future is that, yeah, okay, we demonstrated that we can do this, but we all need to start playing by the copyright rules too. So that'll be a very interesting thing to see what happens next. So yeah, and then beyond that, some models like the one I'm running tonight, Stable Diffusion, you can actually go to a website and actually see all the images it was trained with, millions of them. Other models like DALL-E or the one behind Microsoft Copilot, which is a derivative of DALL-E, that's proprietary. You can't actually see how it was trained. And that's one of the friction points. How do I know whether you used an illegally copyright infringed image? You don't know. It's very difficult to tell. So yeah, great question. Thanks. Yeah.
Does this AI system also do text or is it images only?
The one I have loaded up tonight is text to image. There are other models that do text to text. So I can ask it, for example, to write me a nice email inviting people to this event, and it will actually go do that for me. That's one of the concerns is that because that process is very fast and efficient, it's also being used for things like election disinformation. Write something that will appeal to a particular target audience and make them want to forward it to many people, even though it's wrong. So yeah, there's various versions of this type of thing. There's text to image. There is image to text, which is kind of interesting, auto captioning. There's text to text. There's starting to be some new things that are called hybrid models. Google has one called Gemini that'll allow you to put in text and an example picture and an example video or an example something else many pieces and have it generate a resulting image or document or summary or whatever. Those models can get very big. The latest version of Gemini 1.5 Pro, it can accept up to documents of 2 million words. So you could put in many chapters of many different books and have it create a summary, which is kind of cool. But it's also kind of a little bit of an issue, particularly in the fiction world, where you can say, I'm going to put in examples from my 3, 4, or 5 favorite science fiction authors. Now write me a story about a man who's crashed on a planet, and then publish it. Well, was that your work? Well, that's a good question. I mean, you did all the processing and you chose the reference work, so that was your creativity, but you didn't actually make your fingers type the document. Where's the boundary? We don't really know, right? That's the big issue. If I read all of those books and then I wrote my own story, is that different than feeding all of the text of all those books into a model and having it write a story? That's a good question that we don't know the answer to. It's really, really hard. So yeah, great question. Yeah, thanks.
Some of it reminds me of the advent of the drum machine.
Oh yeah.
People take samples and make music out of samples of other people's music.
Yes.
And at first there was a lot of, well, gee, is it copyrighted? Is it not?
Yep.
Is it public domain? Is it fair use? What are we doing?
And then running with
lazy musicianship or lazy composition, or is it actually an art form itself?
Yes, a great example of that. I'm kind of a huge rhythm and blues fan.
How do you do that?
Yeah.
People make music like that all the time, and it's really natural music.
Yeah.
And also, human beings don't have a lot of tolerance as an audience for people who do lazy music. So it kind of weeded out the effect a little bit.
A little bit, but you know, so like for example, I was about to say rhythm and blues. There are some things that we would call blues standards that many different artists have sung the same song, but in their own style or with their own way of doing it. In religious music, we have lots of things that many hymns that have the same tune behind them, but different lyrics. Is that okay? Or is that lazy writing? I don't know. I don't know. If you've got something you really enjoy, I think we're back around to tacos. I like tacos, and you know, you put some chicken in there, put some meat in there. If you put pineapple in it, is it still a taco? There's a question, right? What if it's got ice cream? Is that making an ice cream cone or a taco? I'm not sure. These are strange questions that keep us up at night. So cool. Yeah, ma'am.
So what about the whole issue of bias or unintentional bias in the training? I mean,
yep, that is a huge problem. There's some examples I actually use in one of my other classes that I teach about examples of unintentional bias. One of the more interesting ones was a study that a group called ProPublica did about a piece of software by a company called NorthPoint. NorthPoint provides what's called sentencing recommendation guidelines. So you basically provide the program, you ask the person a 100 question survey, you put in some other demographic data, but you don't ask them things like protected factors, sex, gender, race, age. You don't ask them any of that, but you ask them all these other questions. And then the idea is it's supposed to present to the judge, here's what is probably a reasonable sentence for this particular crime. What happened was about 13 or 14 states in the United States said, that's the way we want to do it because the computer said so. We want to take the judgment or fuzziness out of the process. And unless the judge has a very good reason, you have to follow the guideline. Yeah, you can see the problem coming from a distance, can't you? What happened and what ProPublica discovered was that going back through the case history data, it was consistently recommending harsher sentences to people who happen to be Black. And they're like, wait, but we never asked if this person was Black. You're right, you didn't. But you did ask, do you know anybody who's been in a crime? What neighborhood do you live in? What kind of job do you do? Those are what are called proxy variables. You didn't ask, but you effectively knew. And they didn't screen that out of their training set. So the net effect was, if you had a possibly biased judicial system, all you did was replicate it with a computer. It did exactly the same thing you just had. So it was a really big case that came out in 2008 was their initial publication. There was a fairly spectacular explosion. Lots of people sued lots of other people. It became a giant mess. And then the part that I use in class is, what about the coder who developed it, right? So what about the computer science who did the work? Turns out the core algorithm, the thing that does the math, came down to one guy, literally one man. And he got called to the witness stand and said, is your system biased? And he said, I don't know, and I don't care. You gave me input, I gave you output. That was the job. So I get to talk a little bit about, I don't care what they told you the job was, keep your brain on, right? You need to think a little bit about this, right? You know, the probably the kiss of death in fate is to say I was just doing my job. Oh boy, that almost never leads anywhere good, right? So yeah, it's a huge issue, and we're definitely struggling with it now. So yeah, maybe too long an answer to your question, but it's a huge issue. Yeah.
Bias can go in a lot of directions. You know, even with your sentence about generated image. You know.
Yep.
There are all kinds. You know, there can be all kinds of bias in what something looks like.
Absolutely. So, in fact, actually, you just reminded me. There's another really great study. I want to say it was BBC, but I could have it wrong. And what they found was that whenever you asked one of the public image generators, and I don't remember which one it was, draw a successful doctor, you never got a woman, you always got a white guy. If you asked somebody to draw me a picture of a thief who robbed a liquor store, you always get the same picture. Well, why did it do that? Because it was trained on all the stuff that's around us. The problem is that the AI doesn't know the difference between all the stuff that's around us and the part that we actually wanted to replicate. I kind of relate it to this. There's a structure in kind of the business side of AI where we talk about data, information, knowledge, action. Action is the only thing we really get paid for. Everything else is work. But in the other axis, there's a big difference between data, knowledge, wisdom. And what scares us on the AI front is something that has infinite knowledge and zero wisdom. That is a big, big problem. And if you ask a random person on the street, or even me, what makes someone wise, that is very hard to categorize. Artificial intelligence is one thing. Artificial wisdom is really much more complicated. And somebody once, I think it was Mark Twain, who had said, common sense just isn't all that common. Right. And that's the gotcha, is we have infinite knowledge and not enough wisdom. That's the problem. There's actually another one I like. It's a German proverb that says, good judgment comes from experience. Experience comes from poor judgment. Right. So that's the reality. Yeah. Yes, ma'am. Yes, exactly. Ethics is very context dependent, right? And very time dependent. Something that makes sense in one moment might not in another, right? A great example of that, if you ever get a chance to watch it, there was a Will Smith movie called I, Robot. It's not very closely related to the original Asimov books, but it's a good movie of its own. In that, one of the critical scenes that happens is a robot basically has to rescue either Will Smith's character or a child who are both drowning in a car. And the robot rescues Will Smith. And it's like, well, and he's mad about it. He's got survivor guilt about it. He's like, well, why did you do that? Because there was a 34% chance you would survive and there was a 28% chance the child would. And he's screaming at the AI going, you're supposed to save the kid. I followed the percentages. And then if it was a human in the same situation, because they say they did wrong, man, you know, that's a hard one. That is really hard. And we're not very good at it yet. We're not very good at it as humans, let alone making a box do it. So that's a really tough thing. And yeah, one of the classes I'm teaching this next semester is actually professional ethics. And part of the fun I get to have is tossing them jump balls like that. Well, what did you want to do? what was the right solution in that situation? That's a very good one. Are ethics constant? Are they culturally dependent? Are they condition dependent? Do they change based on society's point of view at one point in time? Or are true ethics something that's universal and independently correct? Those are hard questions that we've worked with as far back as we have written history. Those are really tough. Cool. Yeah, shoot.
I was just wondering, I know this is probably not a fast question, but
okay.
The new understanding of how creativity might work, how do you see that as affecting AI? You said that maybe will change the way that we think about it.
It absolutely does. Yeah.
Bare bones of how.
The bare bones of how would be, what is my little stable diffusion model doing right this second? The answer is nothing. It's waiting for me to give it another prompt. So it's a stimulus response machine. I give it a stimulus, it gives me a response. But if creativity works based on what the Oxford study says, what should be happening is it should be running all the time, constantly making associations and effectively daydreaming. And then it gives me a creative output when I get its attention. A little bit more like, you ever notice how kids are really super creative? That's mostly because they don't have a lot of inhibition, right? Kids aren't initially afraid of what their friends are going to say. They enjoy playing with crayons and drawing pictures. And it's only when somebody later says, that's not a good picture, that they get some kind of negative reinforcement, right? And by the way, sometimes your picture is truly ugly. But that doesn't mean we want you to stop drawing pictures. It's all in the moment about how you communicate that, right? If those things are true, then fundamentally we have everything about neural networks backwards. They should be running all the time and only give us outputs when we get their attention, just like talking to you rather than daydreaming in the middle of an interesting meeting. That's not what we do now. And the biggest problem I see with that goes back to the energy problem. Put this in perspective for you. The largest neural network models we have today are roughly the size and complexity of a house cat brain. Now, I have a house cat. My house cat is named Wicket. Wicket is about 8.5 pounds of idiot. I mean, don't get me wrong. I love my kitty. And my kitty lives in my barn. My kitty does a fantastic job of keeping mouse out of my barn, but she's also the cat that will sit outside the door in the rain with the door open and look at me and go, meow, meow. The door is open. It's raining. Meow, I'm wet. Meow. Really? But here's another interesting thing to think about, though. I've actually went back and figured out how many calories are in cat food and converted calories to watt hours of energy. She runs on about 1/4 of a cup of cat food every day, which turns out to be about 40 watt hours of energy. Okay, my phone in my pocket right now will barely run all day on 120 watt hours of energy. And I'm not doing hardly anything with it. And for her, that 40 watt hours has to cover thinking, sensory input, oh, and also locomotion and propulsion, purring, shedding all over everything I own. Everything is in 40 watt hours, right? The biggest neural network today requires 40 megawatt hours of energy, the equivalent of a nuclear power plant, all of its output. So we in the AI field, we're not even in the game yet on energy efficiency. How did this happen? Well, this happened because during my lifetime, we pursued performance at the expense of everything else. The only thing that mattered was building something that was higher performance, bigger, stronger. We never considered efficiency. Never came up. Now we're paying the piper. Congrats, you've reached the level where you can start to do things like what we just did, but look at the size of the power supply in this mess. And that's to draw just a little bitty thing. And when I want to draw those big pictures, I'm sucking up enormous amounts of juice. So in order for us to fundamentally change creativity and go to the default mode network kind of thinking, we have to do something fundamentally different on the energy front, because we cannot take big models like this and run them continuously and then ask them questions, unless we want to build a lot of nuclear reactors or a whole bunch of solar fields, because we're going to be at this and generating way too much energy consumption to make it work. Turns out it's a pretty complicated design, a lot harder to do than you first think, but it's pretty amazing too. So cool, great question. I ran you guys way over time, but I hope you enjoyed it. So I found it interesting, and you know, continue to look into it. You might be surprised. Maybe what you need to be creative is just to go shake your tail feathers once in a while. Get out and go see something else. You never know. Very cool. Have a good evening. You bet.